This is demo 2.4, creating and executing unit tests. And in this demonstration, we're going to focus on really a high-level overview on how to create unit tests and how to execute them with the PyTest framework. So let's just scroll down, and we're going to select our classic compute cluster. Again, it should be lab user with a bunch of numbers. Yours will be a different cluster. Again, if it's not started, just go to more and find it, and you can restart it and wait a few minutes. And really, let's start with just a kind of high level overview of creating simple unit tests, right? In this case, we're doing it with the Databricks notebook, but this could be done outside of Databricks. In our case, we're just going to stick to using the lab here in a notebook setting. To perform unit tests, we just broke it down into 3 parts, right? Create your initial project function, production function, and then take that function and decide on how many unit tests to create for that function. In this demonstration, this is a very high level overview. I mean, you could take weeks on just learning to create unit tests. In this case, we're going to create one production function and then just create one unit test for it. Theoretically, you might create more unit tests based on the complexity of your function. And then lastly, execute those unit tests. So we're going to build the knowledge of this demo. So again, create an initial function, your production function, create one or more unit tests to test its functionality, and then somehow execute those. In our case, we'll use the PyTest framework. So to do this, we're going to kind of view our custom functions for this project. So if we go to this folder, and if we go back a folder to the main DevOps Essentials for Data Engineering folder, and then we have the source folder. So in here, we have helpers and DLT pipelines and a final visual, which we'll get to later. If you go to helpers, you should see project_functions. You could manually navigate, or you could just click the link, but just to show you where that is. And this is from the modularized PySpark code demo, which we've taken these functions we talked about in a previous demo, and we just put them in a .py file. And this is just a simple .py file called project_functions within helpers and source. These are the same exact functions we saw earlier. We have a third one that we didn't see, but we did see, actually. We have the third ones. So again, it's just a .py file. It's not a notebook, just a normal .py file. We've imported the required packages. So I'll go back up, just close that one, and get back here. So we have these functions, right? Def, get health schema, high cholesterol map, group ages map. Again, very simple example. Close that py file. And now what we're going to do is run the cell below to import those functions from the really helpers module, right? These are custom ones. So there's different ways to do this. This is kind of the simplest way. We're going to import these two, sys and os. We have to do it this way because, if I go to my notebook, technically this notebook's being run from this location. So we need to tell Python, we want to import something from source, from over here. So from this DevOps Essentials for Databricks source, and go import something from there. So we're going to add a path for Python to go and search for a package. So sys.path.append is what we're going to use. So get the current path of this notebook, go 2 levels up from this notebook to the main course folder, and just append that path so Python can try to import the packages from there. And I will run this. It should give you a note, and it should end with DevOps Essentials for Data Engineering, right? It's just pointing to this main folder, right? We're in here 2 levels in. So now that it knows to go search this location, we can say from src, right? So I'll click on that. Helpers, click on that. I'm going to import project_functions, which we already saw contains our production functions. So we have these 3 functions. Let's perform some very, very simple unit tests. So we're going to create a test function called test get health CSV schema match. It is extremely important to 1, name your function with like a test underscore, and 2, name the function exactly what you are testing. In this case, I'm just testing the schema is what I expect. And then we're going to test the get health CSV schema function from project_files, right? When we already saw that, which we can now import over here. So we're going to create a variable called actual schema to hold the actual schema, expected schema to hold the expected schema we type in, and then we're going to just check and make sure they're the same thing. That's really it. That's all we're doing. Again, these can get more complicated and a lot more tests to build, but for simplicity, that's all we're trying to do is just test the things we built, and we expect them to return what we think they'll return. And if something's wrong, we got to go fix something. So we'll import some packages. The key here is from pyspark.testing.utils. We're going to import this assert schema equals. Again, there's a variety of other packages and stuff you could use. In this case, we're just going to use the PySpark testing utils. Here's the function, the unit test I'm building. Here is project functions get health schema from over here. And it's just going to store what my function returns, right? Nothing special. And then I'm creating this expected schema. So I physically typed in what that function should return. Simple example, the logic is sound, right? What you're trying to do. And then you're just going to say, did that function return what I expected? And we'll just run this cell. Oops, I forgot to import my packages. It's important to import them. And then run that and test pass. There we go. I forgot to import the package, my custom package. So that's it. It's really the hard part is writing all these unit functions and thinking of all the scenarios you want to test. None of this code is terribly complex here, right? It could get a little bit more complex based on what you're doing. So that's really it here. Now, the key is, what if your function, right, if it was more complicated, didn't return what you expected? That's when the unit test says, hey, something is wrong. Either your expected is off or your function itself is off. And that gives you the idea quickly, kind of that continuous integration process. Hey, go fix something is broken. You can also see if the project is big and you have multiple developers, pulling from a version control, and you've already built a function, someone goes to change that function, right? And maybe they didn't realize you're using it somewhere and they change it. Well, the unit test should break and kind of stop them from pushing that code to your main version control system. So that's really how this is all kind of coming together for our really CI and the CI/CD. So next we're going to test the high cholesterol map function from above. Call it test high cholesterol column valid map. Mouthful, but pretty much know what that is doing. We're going to use assert data frame equals to just compare that. We will do actual df, just store what the function returns. The expected df, I'll manually put what I expect that function to return. And then we'll just test the two things and are they equal? Okay, so here's my import of assert data frame equals. Here is my test unit test function. Again, this is a sample data frame. So 0, 1, 2, 3, 4, and none, right? A couple things I like to test are nulls. So in this case, a none. I should probably test a negative. This isn't a very in-depth test, but you should be very careful in these tests and really think about, what data can come into that table or that data frame that could cause an issue. And you really want to test those. Here, these are extremely simple. So we haven't really went too deep into this, but here's the sample data frame. Actual df takes a sample data frame, uses with column, creates a column called actual, and then just uses our function and creates a new column, right? Nothing special here. We should get certain values. Now, again, looking at my function, these are the values I expect. 0 should be normal, 1 is above average, 2 is high, 3 is unknown, 4 is unknown, none is unknown, right? That's what I expect that function I created to return. So I expect it to have this. Here's my expected df and my actual. Then we will do an assert data frame equals from PySpark. Just test those two. Are they the same? And I'll put a little note that they passed. And bam, look at those. Those pass. So whatever I've done worked. Again, if it failed, now you got to go dive deeper. So let's see what happens when it does fail. In the cell below, we've just taken that expected underscore df variable and just changed a value just to purposely make this fail. So this will fail. Again, cell causes an error. So when you run this, you will get an error, and do not fret. That was on purpose. And what we've done is we've changed 0 to return in our expected df bad value cause error, just to purposely break this, right? Sometimes a function will break it. Sometimes your expected df is wrong. But I just want to show you what will happen. Everything else is the same here. We're using the same high cholesterol map. Everything else is the same, except the name, test high cholesterol column invalid map. We do want this to break. So I'll run this. And if I scroll down, so it did break, so that's good, right? And it's telling me those two data frames don't match. And actually 17% of that data frame does not match. So this is actually quite detailed. It's telling me something's wrong. In the data frame, 17% is off. So what this is telling me, if I've never seen this before, is something is broken, right? The unit test is broken, or the original function is broken. If this project was around for a year and a developer was messing with, in this case, the high cholesterol map function, so a new developer came in, first year on the job, first week on the job, and try to change this function to add something to it, to modify it for his or her specific need, the unit test should break because it's saying, hey, it's not doing what it should, right? This is what it should do. You've changed it. Something's broken. So again, think of that for your whole process, right? Now, could you go and modify these to change? Yeah, but it's kind of a stopgap that says, hey, something is now broken. You need to go look into it. So developing good unit tests is extremely important. I mean, we could teach a class for months on it. This is about 15 minutes on unit tests, but hopefully this is changing your train of thought on how to develop a project. That's kind of what it's going for. So now we want to create a file for the unit test. So we did this in a notebook, and that's fine. It'll work. We could do a %run, but the best way to do it is put the unit tests in a .py file. Put it in a .py file and then just import them, right? It organizes your code base. Then you can run these. And I'll show you how to run these in an automated way, which is extremely important. So we'll first start with importing PyTest. And the PyTest framework is a way to automatically run your unit tests, and it gives you a nice output. Again, we could spend weeks on just teaching PyTest. This is an extremely simple introduction. So this just ran, good to go, install the package. So next in this unit test folder, we've actually just put the functions from above, or excuse me, the unit test from above. So if you go to the main DevOps folder, test, unit tests, we actually put the files in there for you, or excuse me, the functions in that file for you. So I can right click and open in a new tab, or I just provided the link here. We'll just select the link. And we're importing PyTest, kind of the other things we need imported. So I'm not going to go too deep into this. Again, you can look up different PyTest tutorials. This is just a very simple introduction. But here I'm importing source helpers project functions. This I find can be a little cumbersome to get working with PyTest. Again, we're just not going to go into that much detail. I'll show you what we did here. A PyTest fixture, just think of this as what it's going to do is it's going to set up a Spark session, and it'll run it when we need it for any of these unit tests. So for example, def spark is going to create or get a Spark session. Yield says, okay, at the end of the test, make it do something else. We could, terminate the Spark session if we were doing this locally. In this case, we don't want to terminate the Spark session in Databricks. And then test get health schema function we saw earlier. We don't need a Spark session here, so we can skip that. But test high cholesterol column valid map, we do need that Spark session coming from this, what's called a fixture. So that's something to look up on your own. We will not go into too many details. You can create fake data that way and then apply it to your unit tests as well. Essentially, when you want to do something for every unit test, but you don't want to manually put it in each unit test, we'll use that fixture. Anyway, so our functions are in here, right? We saw those earlier. These are just our unit tests. I'll close out of that. Here's some information for you if you want to go through it. Big note, again, the complexity and thoroughness of your tests really depend on your organization's best practices, guidelines, and strategy. This is an extremely simple demonstration, right? But hopefully this is kind of changing the way you're thinking about really developing your projects. And we're not going to go deep into PyTest or any other framework here. So next, we're going to execute PyTest within Databricks. It's a little bit different than doing it locally. So if you've done it locally, it's a little easier locally, like in VS Code. And you can run these locally with Spark in VS Code, but we're doing this within Databricks. And here's some notes. I won't go too deep into all of this. We'll talk about it within the code itself. So really what PyTest is going to do is it's going to go where you tell it to. And if it finds anything with like test underscore in the function name, it's going to execute it. That's pretty much it. It's going to execute it and give you a report. So if you have a file like test underscore example.py, you tell PyTest to go to that folder. It'll find that, find any function with test underscore in it, and then run it. So depending on your organization's best practices, you can run unit tests with Databricks or locally in the IDE of your choice based on your specific needs. In this case, I'll import PyTest and sys. Here again, this just removes some kind of bytecode or caching that's being run, which could cause an error in some read-only environments here like Databricks. So we're just going to Don't write that bytecode, just avoid any issues there. PyTest.main will execute our PyTest. So this is saying PyTest execute, go back 2 folders to this unit test folder from this notebook. And I'm specifically telling it to execute this file. If I remove this file, PyTest would go and find it. And if it found multiple files, it would execute all those as well. I'm being very specific here. Hey, just execute this file. V is verbose, and this is some caching information here. And then if it fails to work, we'll just get an error. So this is how we're running it in Databricks. We'll run this. Oh, and while it's running, I want to point out this pytest.ini file. And again, this is a PyTest feature. You tell it where to start importing your paths. And here I'm just getting rid of some warnings. Again, just something to look into. It helps control the configuration of PyTest. But look what it did. We had 3 test functions, and it executed all 3 and all passed. Pretty cool. Again, you can see this can get much more complex as the project gets bigger. So again, automatically discovered the unit tests in that file, and we contain those unit tests. For more information on PyTest, you can check out the documentation. But in the end, just unit testing is extremely important, and it's much more complex than we're showing here. Really thinking of all the tests that you need to build. PyTest is just one framework you can use. There's other frameworks. And then kind of some next steps with unit tests, and we won't cover it too deep in this course, but something called GitHub Actions where you can execute your unit tests as you're pushing code to your version control. And you can check out that documentation here. So take a look. But in the end, unit testing is extremely important. And this was a very simple introduction. So thanks for watching. See you at the next demo.